My name is Marcel Knecht, and I will explain how perpendicularity can be measured on a machine tool. Here we have a machine with horizontal and vertical guideways. I would like to measure how perpendicular the vertical guideway of this machine is, here shown in blue, in comparison to the horizontal guideway, here shown in red. Prior to starting with the actual measurement, I would like to explain the term perpendicularity. Perpendicularity is not defined as an angle, but as follows. First, you measure a reference line, here on the red horizontal guideway. And afterwards, a line on the blue vertical guideway. In our example, the measured values of the reference line on the red horizontal guideway are aligned according to endpoints. Perpendicularity is now defined as the smallest distance of two lines which are perpendicular to the reference line and which accommodate all points on the vertical line. This is the official symbol for perpendicularity. It is read as follows. The reference line is defined by the outward triangle, here the lower side. The side which has to be perpendicular to the reference is defined by an inward triangle, here the right-hand side. When measuring perpendicularity, the angular error of the instrument has to be taken into account. What is the angular error? Each instrument with an angular base has a small angular error between the vertical and the horizontal base. That means the perpendicularity of the instrument is never exactly zero, but the two bases are either a little bit too open or a little bit too closed. Graphically, you have to imagine this as follows. If the bases are too closed, then the horizontal base is pointing slightly upwards if the vertical base is sitting on a perfectly vertical plane. The angular error of the instrument will then have a positive sign. If the bases are too open, then the opposite is valid. The horizontal base is pointing slightly downwards if the vertical base is sitting on a perfectly vertical plane. The angular error of the instrument has a negative sign. The angular error can change over time. For example, if the temperature changes, or due to wear and tear of the surfaces of the bases. In order to use the correct compensation value, the currently correct angular value has to be known. For a new instrument being used at 20 degrees Celsius, or 68 degrees Fahrenheit, and for which a long-form certificate has been established, the angular error can be taken out of the certificate and can be entered in the software as a correction value. If the instrument is not new or is used at temperatures other than 20 degrees Celsius, the correct value has to be determined by a measurement. To do this, we require a very accurate reference, a so-called master. On this master, we have to carry out 4 measurements, 1 measurement each on the left and the right vertical sides, and a reversal measurement on the top of the master. It's important to hold the instrument vertically. We can use the cross vial to verify this. After having measured all four values, we can calculate the angular error. Our instrument has an angular error of +1 micrometer per meter. Now that we have determined the angular error, we can start with the actual measurement. Let's recall. We would like to measure how perpendicular the blue vertical guideway of this machine is in comparison to the red horizontal guideway. That means the reference is the horizontal guideway. We open the LevelSoft software and choose the object's squareness, and then the option Reference equals bottom. The horizontal guideway has a length of 1,125 millimeters, with a base length of 150 millimeters and a step length of 125 millimeters. We will need 9 measurements. The vertical guideway has a length of 625 millimeters, with a base length of 150 millimeters and a step length of 125 millimeters. We will need 5 measurements. Now we enter these values in LevelSoft. Since we have just determined the current angular error of our instrument, we enter this value here. Now we start with the actual measurement. Important: instruments with angular bases are prone to be heated up by the body temperature of your hands. We strongly recommend not to touch the base, but to use gloves or a rag. The measurement gives the following result. The horizontal guideway, which is the reference, is shown to the right with a red line. It has a straightness error of 9.92 micrometers. The vertical guideway, shown to the left in blue, has a straightness error of 1.64 micrometers. To calculate the perpendicularity, the software adjusts to the reference line and calculates the deviation of the vertical line. To adjust the reference line as well as the vertical line, there are 3 methods: adjustments according to ISO 1101, adjustment according to endpoints, and adjustment according to regression. Consequently, there are possible combinations with a total of 9 values. I would like to refer to our video Straightness, where these 3 methods are explained in more detail. In our example, we choose the adjustment according to endpoints. We therefore press F8. The software is now showing us the perpendicularity for the 3 options of the vertical line. If the vertical line is adjusted according to ISO 1101, then the perpendicularity is 18.82 micrometers. If we choose the adjustment according to endpoints, then the perpendicularity, in this case, is 18.82 micrometers as well. And for an adjustment with regression, the perpendicularity is 18.95 micrometers. We have finished the measurement. Seminars and product training on the subject of inclination measurement are carried out regularly. Please contact WYLER AG or our representatives. You may find details on our homepage. My name is Marcel Connect, and I would like to thank you for watching. Additional information on WYLER precision inclination measuring instruments can be found under www.wylerag.com and on our YouTube channel. Thanks again.